This is the solution video for problem set 8, problem 4, and I realized I forgot my calculator just before starting this video, so I won't be solving all of these because some of them I can't do in my head, but I will do my best to show you the way. And that's really all these videos are for anyways. So I'm doing a 2 to the 3rd input AND gate can be implemented using 2 to the 3rd minus 1, 2 input AND gates. So let's reduce the problem even further. What is a 3-input AND gate, and how do I do that with 2-input AND gates? Well, I would want to AND 2 together, and then I want to AND the third one with those. Well, if I want to make a 4-input AND gate, just keep doing the same thing. 5-input, 6-input, 7-input, 8-input. I just keep doing the same thing over and over again. So here I need to use this approximation, and that's just all that tells me. So for all subsequent parts, we will consider different implementations of a 256K cell memory. Please keep answers as powers of 2 when numbers are large. Well, that helps me a little bit. So 2 to the 8th times 2 to the 10th equals 2 to the 18th. Just want to keep that in mind. So, suppose that no coincident decoding is used. What is the size of the decoder? Well, if this is got a 256K by 1, the size of the decoder will be 18 to 2 to the 18th. How many AND gates are used and how many inputs do these AND gates have? We will have 2 to the 18th AND gates with 18 inputs. So how many 2-input AND gates are used? So essentially these are 18 2-input AND gates, so this is just 18 times 2 to the 18th. So suppose that 2-dimensional coincident coding is used, and there's a mistake here. If the row decoder has size 5 to 32, what is the size of the column select decoder? So 5 to 32 is going to be 5 to 32, so I'm going to take off 5 from 18. So the column decoder is going to be 18 minus 5, which is 13, to 2 to the 13th. If the row select decoder has 5 to the 32, how many 2-input AND gates do the row select, another typo, and column select decoders have? Please express the total number of 2-input AND gates. Da, da, da. So we're going to have 13 times 2 to the 13th plus 5 times 2 to the 5th. And that equals some number I can't do in my head. Now repeat part 1 for a row select decoder of 6 to 64. And so this is going to basically change this from 13 to 12. So it's 12 to 2 to the 12th is that part. And then I'm going to have 12 times 2 to the 12th plus 6 times 2 to the 6th, which equals something which is smaller than this. I can just know that 2 to the 12th is significantly smaller than 2 to the 13th. So that's good. So what sizes should be chosen for the row select and column select decoders so the total number of AND gates is minimized? So 2 to the 56K, we've got 2 to the 18th. Basically we want to make a square because that minimizes our perimeter essentially. So we're going to have 2 to 2 to the 9th for both. Or sorry, 9 to 2 to the 9th for both. And how many 2-input AND gates do these decoders have? So this is going to be 9 times 2 to the 9th plus 9 times 2 to the 9th. Part D is suppose a 3-dimensional coincident decoding is used in this scheme. The address bits are split into 3 components x, y, and z. 3 decoders are used. If the x select bit has size 3 to 8, what sizes of the y select and the z select decoders? Well, so we still have this 2 to the 18th address line. So we have this 18 to 2 that we're working with. So this 3 to the 8 basically is reduced this 18 down to 15. And so we've got 15 remaining. So I can split those evenly as possible between y and z. So I'm going to choose y, y select. We'll have size, so 15 divided by 2 is 7.5, so we'll do, this one is 7 to 2 to the 7th. Z select will be 8 to 2 to the 8th. Again, this is not unique. Any two numbers that can add up to 15 are acceptable here. How many two input AND gates? 7 times 2 to the 7th plus 8 times 2 to the 8th plus 3 times 2 to the 3rd. It's pretty big, but smaller than before. So repeat part 1 for an X-select decoder of size 8 to 256. So 18 minus 8 is 10, and so basically I want to divide that between the two of them. So my Y select, so 10 divided by 2 is 5, so I'm going to do 5 to 2 to the 5. Z select will be 5 to 2 to the 5. What sizes should be chosen for the X select, Y select, and Z select decoder so that the total number of AND gates is minimized? I want to do a cube root function, so 18, not cube root, yeah, no, not cube root, divide by 3, 18 divided by 3, so it's the cube root of 2 to the 18th, so which is 18 divided by 3 is 6, so I was right, just got my brain confused. So X select equals Y select equals Z select, which is going to be 6 to 2 to the 6th. And how many two input AND gates do these decoders have? So 6, 2 times 2 to the 6 times 3. Which, actually I want to keep them in the same form, so 6 plus 6 times 2 to the 6th. Which equals some number I can't calculate in my head.